Hey, welcome back. So now we're going to look at balancing beta decay, and this is a little bit trickier actually, but essentially in beta decay in the nucleus we take a neutron and we change it into a proton plus an electron, and the electron, remember, is what we call the beta ray or beta radiation or the beta particle, depending on what you want to call it, I suppose. The proton stays in the nucleus, so that's why the atomic number increases by 1 and changes it into a brand new element. Now, the interesting thing is that the mass number, right, must not change at all. So the mass number of the element must be unchanged. And why is that? Well, the mass number is the number of protons plus the number of neutrons. And all you're doing in beta decay is basically taking away one of your neutrons and replacing it with one of your protons. And so you can see the net result is no total change here. So the mass number is the number of protons and neutrons. If you make one bigger and one smaller, the net result is no change whatsoever. So we can write our electron as a beta particle, and the mass number, right, which we would normally put on the top for an atom, we're going to go ahead and write the 0 there. So that's very interesting. Now, the really cool thing is that the atomic number of the daughter element must increase by 1. And so you remember when we were balancing our equations, right, we made sure the number's balanced on each side. So if the number of protons goes up by 1 on the right-hand side, we must go ahead and assign the electron a atomic number of -1, so that when we add those two numbers together, it balances out. So if you like, the electron is -1, and that means that the daughter particle, it gains an extra proton, so +1, and when you balance, you just make sure those numbers add up to the same thing. So very cool, huh? So let's go ahead and work through an example. So iodine 131 undergoes beta decay, and the beta particles actually can be used to destroy a tumor. So for instance, you know that the thyroid gland will actually capture iodine in your diet. And so if you've got a tumor on your thyroid gland, then you can eat this radioactive iodine and it will be absorbed and concentrated in the thyroid gland. And when it decays, it will actually destroy any tumors that are next door to it. Iodine is atomic number 51. So what is the balanced nuclear reaction? Well, it gives off an electron. And remember in the last slide, right, we said the electron essentially has no mass number, has no protons or neutrons, and the atomic number we write as -1. If you like, the electron is the exact opposite of a proton. Or if you like, it just accounts for the fact that the daughter element here is going to gain 1 proton. So in order to keep both sides balanced, the electron has to act, if you like, as -1 proton for it all to add up. And let's go ahead and write this down. So we're going to go ahead and write X there because we don't know what it is. We know that the mass number must be 131. So notice 131 equals 131 plus 0. The bottom number here, so we got 51, is equal to -1 plus this thing over here. So this thing over here must be 52. And again, remember in beta decay, you're essentially just changing a neutron into a proton plus an electron. So changing a neutron into a proton doesn't change this number here, but you've got one more proton, so now it's not 51, it's 52. And if we look at our periodic table and we look at element number 52, it is actually xenon. So actually X was a pretty nice choice there for the element symbol. And so xenon is what is formed. So let's go ahead and write a couple more. In fact, I'll go ahead and have you do these. So let's go ahead and look at carbon-14. It undergoes beta decay. And how about uranium-237? And it undergoes beta decay. What is the product of these two nuclear reactions? So go ahead and pause, have a go, and then unpause in a couple of seconds, and we'll go through it. All right, so we have to remember a beta particle is an electron. An electron, if you like, has a mass number of 0, and because an electron's the opposite of a proton, it has an atomic number of -1. So in our daughter, right, we can go ahead and we can say that the top number must be the same, because 14 equals 0 plus what number? That number, of course, is 14. The bottom number, 6, is equal to -1 plus, well, that must be 7. And if you remember, in beta decay, we turn a neutron into a proton. And we can do the same thing for the uranium. So the uranium, right, will form a daughter element with the same mass number, and the atomic number will go up by 1. And I suppose now we need to look up on our periodic table, right, what these elements are. So let me erase the X Okay, and then what is element number 7? Element number 7, I believe, is nitrogen. And element number 93, so that is Neptunium. And so NP for short. And so those are the products of those beta decay processes. Good job.